Hi, welcome to my talk on enriching a terminology for under-resourced languages using knowledge graphs. This is joint work with my colleagues at the National University of Ireland Galway, Atul Ojha and Bharathi Raja, my colleagues at Dublin City University, Ian Kelly and Patricia Buffini, and my colleagues at Translators Without Borders, Grace Tang, Enrich, Paquin and Manuel Locria. So, terminology is something that's very important for aid workers in the field. A famous example of this was after the 2012 earthquake in Haiti. The NLP community very quickly came together and they developed a very large number of resources for Haitian Creole, a language which otherwise had, or to this point, had barely been touched by language technologies. And this was very helpful in the aid effort in Haiti at the time. So this is kind of the mandate of this charity, Translators Without Borders. It's a non-profit organisation and the goal is to develop language resources for aid workers. So they approached us because they realised there's a lot of open data available for lexicography in open resources such as WordNet, Wiktionary, Wikidata, which, well, it's not lexicography but contains a lot of information that can be very useful in constructing lexicographic resources. So the goal of this collaborative project between the ADAPT Centre and Translators Without Borders was to try to enrich their resources by using open lexicographic resources. So the particular context of this project was the Rohingya refugee crisis. So Rohingya is an ethnic group, mostly in Burma, and they were recently forced out by the persecution of the Burmese government, and nearly all of the Rohingya population has fled Burma, with nearly 1 million of them going across the border to Bangladesh. So there's a huge humanitarian crisis here, but there's also, for the linguistic aspect, this is quite challenging. So obviously the main language in Bangladesh is Bengali, but Bengali has a number of different dialects. And this area in green here, near the border with Burma, is a language called Chittagonian. It's quite different from standard Bengali and can be quite challenging for aid workers who have maybe only got dictionaries that cover standard Bengali. So this means that we're actually doing a project that is focusing on 5 languages. So first of all, English is the language that most aid workers would know. The 2 national languages that are associated with this crisis, so Bengali is the national language of Bangladesh and Burmese is the national language of Burma. And relevant local languages, so the Chittagonian language, which we already discussed, and of course the Rohingyans themselves have their own language, which again is quite closely related to Bengali, but often not mutually intelligible. So we're dealing with 5 languages, 2 of which are fairly uncommon, and Bengali and Burmese are not widely covered by natural language processing technologies, but to some degree. And Chittagonian and Rohingya, as we discovered, have effectively very few resources of any kind. So what TWB mainly make are these glossaries. So this is based on the fact that the effectiveness of any aid program really involves you having to be able to transfer information in the language of the people you're trying to help. If you can't communicate with people you're going to help, it's going to really affect the effectiveness of an aid organisation in that area. So TWB developed glossaries which give frontline aid workers localised emergency-related terminology. So very specific kinds of terms that will be useful in these kind of crisis areas. And the goal of this project is really to try to increase the number and the discoverability and to increase the ability of TWB to expand their glossaries by discovering new associated terms. So this screenshot gives you an idea of the glossary that we're working with as input. So it contains some basic words, so general things like addition and alphabet. And then we have these terms translated into into Bengali, into Chittagonian, into Burmese, and into Rohingya. So we have basically, just kind of parallel lists of words. So the first thing we did was we tried to construct corpora to help us with the natural language processing techniques we wanted to use here. So these, as you saw in the previous slide, are 5 languages written in 3 different scripts. And Rohingya itself can also be written in either Latin script or in Bengali Assamese script. And for the first 3 languages, English, Burmese and Bengali, we could kind of use a fairly typical approach to collect corpora. We could, use the web, use Wikipedia. We could get parallel data from Opus, this big collection of parallel corpora. We also got quite a bit of coverage from the Leipzig University's collection of under-resourced language corpora called Curl. But for none of those resources did we found basically nothing for Rohingya and Chittagonian. For Rohingya, we found a little bit of a corpus. There is something, mostly created again by aid agencies, but there are also a few books, including a translation of the Quran that was available. For Chittagonian, even though it actually has more speakers, because of its effectively being basically a diglossia where most Chittagonian speakers will write in standard Bengali, there's very little written content in Chittagonian. The most we could find was a small amount of translation of the Bible, which we used as then a bootstrap to then try to extract more data from social media. And we looked at Facebook and YouTube and extracted a bit more Chittagonian data from this. So this leads us to actually construct basically the first ever digital corpus of Chittagonian, as well as one of very few digital corpora of Rohingya. Obviously the size of these corpus is much, much smaller. So for Bengali, we had over 10 million words, as we did for Burmese. For Rohingya, we struggled to get 100,000 words, and for Chittagonian, we didn't even manage to get that much. But we still got sizable corpora, which can be useful and can be helpful in terms of the work in constructing these glossaries. So our next goal was to link these up with open resources. So the Translators Without Borders glossaries are in 5 languages. For the linking, we're actually only using the English because it's there and it's available and it's kind of reliable. And we linked these up with 2 particular open resources. We linked it with Wikidata, which gives us the connection to the linked open data cloud, to Wikipedia, to a large amount of data this way. And we linked up with the English WordNet, so the Open English WordNet, which connects us with all of the multilingual WordNet dictionaries, as well as the infrastructure of projects like Alexis, which you probably see in other talks at this conference. So we're basically doing monolingual linking in English, and that's the way we're trying to enrich this. And we do this using a methodology called Nash. This is a system we've been developing for a number of years. It works by taking these 2 dictionaries, running them through this pipeline of NLP tools to try to construct a matching. And I won't go into too much detail about it. We use basically 2 main settings. We use one where we're looking at fairly simple text features, so things like longest common subsequence, n-gram overlap, etc. And then we tried a more state-of-the-art method using the BERT model with a Siamese deep neural network. So I won't go into too much detail because we also have a demo paper at this conference about it, so please come see our demo paper where we talk more about the Nash system, and I can show you it in action. So we evaluated this in a few settings using both the simple text-based methods and using BERT, and we were quite surprised to see that we actually got unexpectedly a result that the simple methods, without trying to supervise and train it, worked best, which is a bit surprising, but it was kind of, the intuition was that perhaps the most important thing was finding correct linkings. So finding good candidates, and actually the selection of candidates wasn't so important. So we got fairly similar levels of performance with all the systems. So this allowed us to actually enrich our glossaries. So what we'd do is we'd then add in a huge amount of extra information based on these links. So we took the linking from the corpora, so we'd find examples, say, of a term from the corpora, which would help the translators and the lexicographers in terms of constructing their resources. From WordNet, we'd get a number of useful terms, a number of useful extra facts. We could get an alternative definition, so we'd have the WordNet definition of the term. We might get synonyms, so alternative versions of this form. So this is obviously the word vaccination that we're looking at here. So we might get inoculation as an alternative in English. And we might get related terms, which might then be words that Translators Without Borders could prioritize for future translation. From Wikidata, we also get some similar information. We get alternative definitions. We get, again, synonyms in many cases, although for vaccination there aren't currently any synonyms in Wikidata. But we get also, again, a lot of closely related terms. And in Wikidata, of course, we get a large number of translations. So for a word like vaccination, we had about 100 translations. So this could be useful for porting this glossary to other languages. We also got images, which can help in this situation to show people the aid work, or to give the aid workers images that they can show to people. And of course we get links to Wikipedia articles to give much more information. So this really enriches the terms from just being a list of terms to now having, you know, a huge amount of extra information for each of these entries within their dictionary. So this was achieved in terms by developing a web application that TWB's lexicographers could use. So this is a web application that used a MySQL backend and an Apache Jena triple store. It would use Sparkle queries to query, first of all, the extracted Wikidata data along with the WordNet data and the linking we have between them. And then it provided a interface for lexicographers where they could choose simply to mark particular terms as includable or not includable within the glossary. So it still gave the lexicographers complete control over what data would end up in the final glossary. So in conclusion, we just saw that open resources can be really useful in improving the kind of data that's available. So from a simple glossary, we could get a lot of extra information, and this was really effective. We could do this even with languages that are, you know, severely under-resourced to the point where they're not very well documented. So we could develop corpora, and we did develop, you know, the first online digital corpus for Chittagonian. So, you know, that's something that we're successful in doing. We got, you know, reasonably high accuracies in terms of linking to Wikidata and WordNet using machine learning methods. So, you know, we show that this is an effective way to kind of connect a resource like this with other sources. Now, probably the biggest issue was the lack of suitable candidates in the open resources. Sometimes, just for whatever reason, the term as it appears in the TWB glossary didn't really match anything that we had. So, you know, the biggest issue is actually losing terms because we don't have an exact match between the title. And finally, we developed this into a tool, which was then applied by TWB in their glossary development process, and we found this could be directly useful for their lexicographers. Okay, thank you.